All right. So today, for most of the year, you've learned how to graph one line. We've talked about slope. We talked about y-intercept. Well, now we actually get into systems that actual two lines. So our focus over today and tomorrow is going to be what does it mean to find the common solution to two linear equations with two variables. So this equation, I hope, should look pretty familiar, right? Oop, I'm frozen. Right? This equation look familiar?
Yeah.
Remember the caps problem? One of the very first things we did when we started this book? So it says the equation related to relating the profit by selling the t-shirts and caps was this, right? And we found lots of different solutions that could make this true, right? Remember we did that?
Yeah.
All right, so the graph is shown here. So 0, 60 was 1. Anyone remember what this point was? The x-intercept? We knew the y-intercept was at 0, 60, right? Because that means when I make this 0, you had to sell 60 caps to make 600, right? What about the t-shirts? Anyone remember how many t-shirts we had to sell to make $600 profit? Anyone remember? What's 5 into 600? Not everybody at once.
120.
120. So this point way out here is 120, 0. So any point, remember we had that big chart, and we made a bunch of points that made that solution true. That means it falls on this line. Okay? So explain what the intercepts mean to the scenario. Well, the y-intercept means that the students had to sell 60 caps and 0 t-shirts to make a $600 profit. That's what it means. When you talk about the x-intercept, they had to sell 120 shirts and 0 caps to make a $600 profit. That's what those intercepts mean to this situation. We should be writing. If you don't have anything in your hands, I don't understand why. And if your pencil isn't moving, I don't understand why. All right. So that's what the intercepts mean. Where's my little book at here? So on page 11, what we're going to get into today. So let's read the story at the bottom of page 11. So if you want while you're writing, I'll just read the story to you. It says, at a school band concert, Christopher and Celine sell memberships for the band's Booster Club. Okay, Booster Club is a group of people that raise money for an organization. An adult membership costs $10, and a student membership costs $5. At the end of the evening, the students had sold 50 memberships for a total of $400. The club president asked how many of the new memberships are adults and how many are students. So it says you can answer the question by writing and solving equations that represent the question and the given information. So down below here in part A on your worksheet here, here's our first task. So let A represent the number of $10 adult memberships and S represent the number of $5 student memberships. Here's what I'm asking you guys to do right now. I'm going to give you guys about 5 minutes to do this. Come up with an equation that relates the number of adult memberships and student memberships, A and S, to $400 income. All right? Make sure you can tell me what the terms mean. And then number 2, I want you to give me 3 solutions that work for that. So A plus S, I want you to give me 2 numbers that can make that equal 400. Any 3 numbers. So we can have lots of potential numbers here, right? All right. And then we'll come together. So I'll give you about 5 minutes. Okay, in your group, I want you to see if you guys can do 1 and 2 here. All right, we're going to pause the video. How many people came up with this for the equation? No, we're talking about money, right? So the adult memberships are $10 a piece. So the 10's got to go with the A, right? But you're talking about cost. So every membership I sell, we make $10. So it's $10 per adult membership. That's why we got 10A. 5S, well again, S they said was the student memberships, right? They cost $5 a piece. So for every student membership we get, okay, That's $5. Now, what most of you probably did is you could have done the trial and error method, right? Plugging in some numbers for this, right? You could have found the intercepts, right? If I had put a 0 in for this, 10 times what gives me 400? 40. So this could have been 1, 40 and 0, right? If we're going to do it like this, okay? And then the other way around, right? If I make a 0 for A, 5 goes into 400 how many times? Not 120, 80. So that's a possible point. What you could have done too is you could have looked at this as like, oh, okay, well if we kind of look at this as a standard form and make it in a slope intercept form, I could plug it into a calculator. It could give me all kinds of points, right? Did anyone think of that way? Remember we spent all that time converting? So I can move the 10A over. I'll pretend that Y is S. I know it's kind of far out there, but watch this. And then divide by 5. Just showing you another way. So again, A is going to equal, this is negative 2S, that's an S, plus 80, right? And 80 is our y-intercept, right? We kind of talked about. So if I were to type that into the calculator, watch this. So negative 2 plus 80. Oh, I got to go to y equals. Negative 2, I'll make the variable here, plus 80. And now when I go to my table, look at all these values that I could plug in to make true. And I could pick any 3 I wanted. So there's another way you could have done it. I don't think anyone thought of that, did you? You may think of it the second time around. All right, so let me erase this. So one group, I want to go around another group. Give me a point that you found besides these two. Stephen, what'd you guys find? Give me another point that you guys found that makes this true. Did you guys find a point? Besides 0, 80 and 40, 0? What'd you find? 20 and 40? Okay. And I'm sure most of you are going to find base 10 numbers, right? You may have tried to plug in a 10 because you saw this, right? And subtract. What about you guys back there? 5 and 70? Okay. We're just kind of going around taking a general consensus. What'd you guys find? Anything different than those 4 points?
30 and 20.
30 and 20? There's lots of them. What'd you guys find? Anything? 39 and 2? That works. I like that. That's thinking outside the box. Because 39 times 10 is 390. 5 times 2 is 10. 390 plus 10 is 400. Did you guys find anything? What you guys? In the back? So these are points that would fall on that line. And there's many more. Okay? Now, let's try to do this one. Now, number 3, notice how the question is a little different. Same scenario, but now they want, what question relates A and S, that's adult and standard student memberships, to the total number of new memberships? Now we're talking about a quantity, a number. We're not talking about dollar value now. So what do you think would be the equation for this scenario? How many adult memberships and how many student memberships made 50? So they want that equation. So we're going to give you guys a few more minutes now to work on that. And then again, you find 3 sets of numbers that give me 50. Okay? So we're going to pause the video again. Give me 2 numbers that when you add them up, give me 50. 40 and 10. Okay, that's a good one. So 40 for A, 10 for S. Good. Jennifer. Huh? 42 and 8. Okay. I add those together, I get 50. Good. Jenna. 30-20, that's one. Good. Joey. 25 and 25, right? That's half. Probably most of you got 25, 25. That's probably one of the first ones that popped into your head. Megan. 48 and 2, okay. Minia. 1535, okay, good. We got the idea here. Brad. 5 and 45. We come up with a lot more numbers, right? We can come up with a lot more numbers. 1 and 49. I mean, there'll be lots of them that add up to 50. Lots of combinations. All right, now, this is where we really got to think. Are there any pairs of values, that means when I take A and S, that not only work to make this equation, but work to make this equation? Are there any sets of numbers that make both equations true? That we have the same point in both of them? I want you to take a quick little conversation with your group. Do you see anything? I'll give you a hint. The answer is actually on the board. We rarely stumble upon putting that number on the board, but it is on the board. What number do you see twice? $30 and $20. So how's that possible? We had one set of numbers that actually made two different equations. Money and memberships true. Okay? Well, when we talk about that, that's what we call a system. So if I were to graph these two equations, by using the intercepts, right? Up here we did 40, 0, which is right here, and 0, 80, which is way up here, right there, and right there. And then I do the same thing for this one. Now we didn't have intercepts for this one, but this would just be 0, this would be 50, 0, and then 0, 50, right? So that's right here. So what happens is when those 2 points meet at a certain point, right here, that intersection point, that's the point where it makes both equations true. That's a system of linear equations. The intersection point of two lines. There's one point that makes both lines true. You could try any other number, it won't work. That is the only number in that order that will make both equations true. So our intersection point of two lines is our answer to two equations, that point they share. Does that make sense? Because again, you can see the two lines touch. That's the only point those two lines share. Every other point is special to that particular line, right? Except for that one point, the point where they touch. So if they sold 30 adult memberships and 20 student memberships, they would make $400, and they'd also sell 50 memberships. And that's the only scenario that's how it's going to work out. And it says that could there be a common solution for two not shown on the graph? No. These two lines will never ever intersect again, right? This line continues to go this way. This line goes this way. It can't touch again, right? Because if it does, it's not a straight line, right? Right? Okay, so you kind of saw it in a scenario. All right? So go ahead and flip the next page. Now we're going to get some practice. What? Yeah. What? I did show them the graph. All right. So, now, it seems like forever ago because last week we M-stepped, but this is why we spent a lot of time doing the converting stuff, because we have lots of different problems here. So our steps say this. We'll do the first one together. So it says change each equation into slope-intercept form, if possible, because some of these, like this one, you can't, right? There's no y. Graph the equations on the same set of axes, so on the graph. And then what does the graph tell you about the number of solutions? Now, if there's one solution, that means it intersects at one point. If there's many solutions, remember way back we had a scenario where it was the same line. Remember we got the same line because they basically were right on top of each other, so they shared infinite, right? If they have no solutions, that means the lines don't touch. All right, and if we do have one solution, do we know where it is? So here's what we're going to do. We're going to do number one together here. So this problem here, this equation, is in standard form, right? X and Y are on the same side. So how can I get it in a slope-intercept form? Who remembers a couple weeks ago when we were doing converting to standard form and slope-intercept form? We got a lot of practice on this.
Move x over by subtraction.
Right, I get the X and Y on opposite sides, right? And to do that, I had to subtract X since X is positive. So now I get this. And that's in Y equals mx plus b form, right? With me, right? Okay. So if I were to graph this line, slope-intercept form tells us two things. The y-intercept and what? What else does it tell us? The what? The slope. That's why they call it slope-intercept form. A lot of thought went into that. So if I go to 0, 4, which is right here, okay, that's my y-intercept. And now, what's my slope? What's my slope of that line? -1, right? Because there's a negative in front of the x. So we're going to go down 1 and over 1. Now, this is going to be important. To draw a straight line, you're probably going to need a ruler here. If you draw it by hand, you may never draw it right to see where it intersects. So I do have some up here. I would encourage you guys, even if you just use a couple per group, but to use a ruler here. If you were to hand draw it, it's never going to come out the way you're going to want it to come out. So I'm going to use my straight line tool. All right. So I'm going to click on the line. I'm going to make it nice and straight. And we're going to draw our line going this way. All right. So there's our blue line. Remember, how many points do we need to make a straight line? 2, right? Y-intercept and slope gives me those 2 lines. Just 2 points to make my line. Draw your 2 points and then make your nice straight line. Make sure that line goes through the center of the points. You want to be accurate here. All right. Well, now we have to do the same thing with the second equation, right? Because is a second equation in slope-intercept form? No. So again, how am I going to put it in slope-intercept form? We'll make this one red. We'll make it a different color. How's that? How am I going to do this in slope-intercept form? Okay, good, Blake. I got to subtract x to both sides. Now when I do that, look what happens. I get this. So is it in y equals mx plus b form? Some of you are shaking your head no. Why? Why is it not in y equals mx plus b form? Raise your hand. Why is it not in y equals mx plus b form, Natalie? There's a negative y, right? So how do we make the y positive? Just erase it? What do I got to do? Blake? Okay, times or yeah, you can you can multiply both sides or divide every single term by -1. That does what? Changes all the signs. So this becomes a y, this becomes an x, and that becomes a 2. Right? And now we are in slope-intercept form. Remember, I had to do it for every term. What you do to the left side, I have to do the right side. So whether I divided it or multiplied it, same thing. Okay? So I get x plus 2. William, what is my y-intercept? 2, right? So where's 2 on the y-intercept on the graph? Where's it at? Is it here? What intercept is this? X. So where's y? Right here, right? Okay. What's my slope here? Sheridan, what's my slope? 1, right? Because we have just an x. We don't write the number in front of an x, right, if it's 1. So that means our slope is 1 over 1, which means we go up 1 and over 1, right? Well, when I go up 1 and over 1, what happens? Yeah, it's this guy right here, right? Was it the same point from the blue line? So what we're going to do now is we're going to make our red line and very carefully go through. Okay, so now to answer the questions above, do we have one solution here, many solutions, or no solutions? We stayed 1. Why? Why is there one solution? Because it only intersects at 1 point. So yes, there's one solution here. Who can tell me what that solution is? It's a coordinate. What point do these two lines share? 1, 3. See that? This point right here, I'm going to color in the shared point. This is at 1, 3. So I can check this. Because if I plug in a 1 here, and a 3 here, right? Is it -1 plus 4, 3? Yep. So it works for that. And then if I go here, isn't 1 minus 3 -2? Yeah. So that's the one point that works for both of them. It's one solution. All right. When you finish getting this, I want you to try number 2. Number 2, though, has a special equation, right? X equals 3. Remember what that line looks like? I told you they weren't going away. Horizontal, vertical lines. Told you guys you got to get to know those. So we got to remember way back what x equals 3 looks like. The other one, you got to put in the slope-intercept form. So when you get done filling out number 1, I want you to give number 2 a shot. See if you can graph both lines and tell me if there's one solution, many solutions, or no solutions. And if there's one solution, what's the point it shares? Talk with your teammates. Remember what kind of line x equals 3 is. It's either vertical or horizontal. You got to try to remember when. So we're going to pause this again. All right, while you're working, because I see some people start. X equals 3 is what kind of line? I'm going to help you with it right now because a lot of you forgot. It is I heard someone just say it. It's a vertical line. So that means where x is 3, all the points that are at 3 make this true. So I want to make sure my line is right on the 3. So there you go. You got one done for you. Now you just got to find this line. And use what we did over here to help you. So we did one for you there. There's the x equals 3. So that means all the x points, no matter what y is, x is 3. Okay? There's your little assistance. So when we convert x plus y equals 4 to slope-intercept form, I subtracted the x over, right? Right? Tell it's a Monday. So I get -x plus 4. So again, we're at 4. And unlike the first problem, where we had to go, we go down 1 and over 1, right? So isn't this the same line? We had number 1, the blue line? Yeah. It's the same line. So we already did that work, which is nice. So we're gonna, oh, I'm a little off. All right, I'll have to fix, hold on. Beauty of technology here. There we go. Still a little off. So I gotta make sure it crosses the center of the, I think I drew my dots were off. And you can see the point that it connects at is like right there, which is at the point 3, 1. Now, we just can't be happy with saying, we're good. Check it. Well, I can't plug in a y to here, right? I can only plug in a x. Well, does 3 equal 3? Yep. And then over here, does 3 plus 1 equal 4? Yep. So it satisfies both equations. Why do you check it? Because let's say if I was a little off and I said, oh, it's 3, 0. Well, it would work for here, right? But it would not work for here, would it? That's why you check it. Don't just take for granted that you found the right answer. Check it to be sure. Okay? Be thorough. It's like when you fly, right? You want that airline mechanic to be thorough, right? You don't want him to go, we look good. Take off. No thanks. Right? You better know how to swim. Okay. Or parachute. All right, number 3. Now, number 3, we finally have 2 equations that are both standard form. I didn't throw any curveballs at you. So let's see if we can work on number 3. Get them in a slope-intercept form. Y equals mx plus b. Let's see if we can graph them and find the intercept point. So again, we're going to pause for number 3. All right. Well, the top one is nice and easy, right? All I got to do is move the 2x over, and I'm in slope-intercept form, right? Because y is positive, and there's a 1 in front of it. So how do I move the 2x over, Sam? I got to subtract it. Very good. Because it's opposite. So I get y equals negative 2x minus 1. So what's my y-intercept? Nolan, what's my y-intercept? It's what? What's my y-intercept? Did you say negative 1? Negative 1, right here. And negative 1 is right there. What's my slope? What's my slope? Ethan, what's my slope? That means what in terms of rise over run? Yep, down 2 and over 1, which puts me right there. Okay? So I'm going to connect the dots. The best I can here. Ooh, that's a thick line. Make this a little more skinny. Okay. There's my line. So now we got to do the other equation, right? So I got to get the x on the other side by doing what? Elise, how am I going to get this x over here? Subtract it because it's positive. Now, here's the common mistake most people make. Is this 2y? What is it? Negative 2y. Don't forget the sign. So when I rewrite this, it's negative 2y equals negative x plus 7. Okay? So now, to solve for y, because we got to make this y equals mx plus b, what do I have to do? Blake. Dividing negative 2 all the way across. So that gives me basically 1/2 x minus 7/2. Okay. Well, 7/2 is what? 3.5, right? So negative 3.5 is right there, right? Between negative 3 and negative 4, right? And I'm going up 1 and over 2. So I'm going to go up to negative 2.5 and then over to 2. So it's like right there, right? With me? So let's draw a red line. And so now, visually speaking, does this have one solution, no solutions, or many solutions? One, because it touches together at one point, right? So this is one solution. Now, what is the solution? It's this point right here, right? That it shares, right? That little one I made in green. What's that point? Not 3, 1. It's 1, that's the x, negative 3. All right. So now we move on to number 4, and my headset is dinging here, so we'll see how much I can get out of it before it goes out on me. We may have to try the computer mic if I yell loud enough, so just kind of bear with me here. So we're getting into number 4, okay? So if you notice here, the equation for number 4, this one, is the same as this equation. So instead of having to do all that work again, we know what the y equals mx plus b form is. So all I'm going to do technology-wise is to help save time, I'm going to copy this on over. All right, and this guy is going to go right there because that's where it was before. Just making sure I got the same spots. Let's come up just a little bit here. Okay. All right. Now, this equation here, y equals negative 3. Well, if you remember from yesterday, we did the x equals 3 is a vertical line. So that means that y equals negative 3 is a horizontal line. And all these points are at y equals negative 3. So if I go across here like that, we get an intersection right there. And if I go ahead and if I go this way, that's x is 1, and I go down 3, our intersection point is at 1, negative 3, which happens to be the same exact answer as what we had in number 1. So we have one solution, again, is our answer at 1, negative 3. All right. And again, if I plug it in, I can only plug the y coordinate in here, so negative 3 equals negative 3, check. And then this one here is going to be 1 minus 2 times negative 3 equals 7. Well, this is negative 6, right? And 1 minus a minus 6 comes plus, so 1 plus 6 is 7. So this does check for both equations. Okay? So again, the first 4 problems, you've seen how we can have one solution where the two lines intersect at one point. All right. Now we're going to get into number 5. Okay. Number 5, we're going to have you pause this video right now. And again, try number 5. Now I've got warmed up with number 4. And see what happens when you solve these into y equals mx plus b form and graph them. So pause the video, and we'll pick it back up in just a minute. All right. Well, the first thing I had to do is I had to take the 2x and move it over here, right? By adding 2x because it's a negative 2x. So I get y equals 2x plus 3. Okay? So that means y-intercept is at 3. I go up 2 and over 1, which puts me there. Okay? And I'm going to make my point. And I'm still dinging here. So we're going to draw my line. As best I can. That's pretty good. Okay. There we go. Now that I got my first line drawn, I am going to do the same thing with this one. So I'm going to move the 4x over by adding 4x to both sides. And I get 2y equals 4x plus 6. And now I need to divide everybody by 2. And I get y equals, this is 2x plus 3. And look what I notice here. This and this are the same equation. So it's the same line. If I go ahead and make my line, it's literally going to be, let me see here. We're going to clone this guy. I'm going to go over the same points, and they're going to share all the points. So when we have the same line like we do here, and you see they copy right over each other, this is many solutions. Because every point on this line is going to match every single point on this line. So again, here's a situation that we had many solutions because they're the same line. All right, number 6. Last but not least. So we're going to go ahead and pause the video again. Give you guys about 5 minutes to try number 6. So go ahead and do so right now, and we will come back and see how you did. Okay, now that you've had a chance to see how you did, well, if you look at number 6, this equation is the same as number 5, right? So it's the same line. So we have a point here, and we have a point there, right? Because we already did that work, right? Y equals 2x plus 3. So I'm gonna move this line on over here. Okay. So we're gonna put him there. All right. Now to figure out the second one, I gotta move the 4x over. So I'm gonna get 2y because I have to add it, right? And I get 4x plus 10. Now this should be a different answer because if you notice, it looks almost the same as number 5, but instead of a 6, they put a 10 there. So when I divide by 2, I get y equals 2x plus 5. All right? So we have the same slope, but different y-intercepts. So at 5 is right there. And then I'm going to go up 2 and over 1, which puts me about right there. So if I make this line, I'm just going to use this line again because we have the same slope. So we're going to make this line red. And I'm going to draw this over here. There it is going through those two lines. All right, so what do you notice about this line here? Do you see an intersection? No, you don't, right? There is no intersection point. So if there's no intersection point, what's our solution? Right, no solution. Because these two lines do not intersect, because they are parallel. They have they have the same slope, but different y-intercepts. So now you see the 3 examples of one solution, many solutions, and no solutions. All right, so let's head on to our last page here. Okay, a system of linear equations is 2 or more linear equations graphed on the same plane, and a solution to that system can be found by the intersection point. Okay, it's a point or points that make both equations true. Okay. And again, at any point in time, you need to pause the video to write this down. Just go ahead and do so. We'll move on. Okay. I'm gonna have to speed up here because my headphones are beeping, which means they are about to go out. All right. So The most efficient way to graph equations in standard form, when you know the intercepts will be very large or the rate of change is unknown, is to solve for the x and y intercepts on the graph. So let's say if you put it in slope intercept form and you get like y equals 18x plus 40, okay, that makes things tough. You want to solve for the intercepts. So again, you do that by plugging a 0 in for x to solve for y, and you plug in a 0 for y to solve for x. Or you can do it what we've been doing the entire last one is convert to slope intercept form, graph the y-intercept, and then from the y-intercept use the slope to find the second point, which is basically what we did on the previous page over and over and over and over again. And again, most of the problems you're going to get, this method here is pretty much what you are going to do. Okay? All right. So, systems of equations will have one solution if the lines intersect at one point. Okay? And usually that happens when the two equations have different slopes. If the two equations have different slopes, they're going to intersect at one point no matter what. Okay? You will have no solutions if the lines are parallel, which means if when you put them in a slope-intercept form, you have the same slope, you have the same y-intercept, so they'll be parallel, which means they will never ever touch, hence meaning you do not have an intersection point. And then you will have many solutions if the lines are the same, which means you have the same slope and the same y-intercept. Okay, they're the same exact line. There is going to be two lines pretty much right on top of each other, and you're going to get them, you're going to share every single point that are on those lines because they're the same line. So those are our three scenarios, all right, which is extremely important. So your homework assignment, since you are watching this and patiently waiting, is going to be, make this a little bigger here. All right, on page 15 and 16, 22 to 24, 18 and 19, 51 to 56, and on page 20, 58 to 62. And that will be due tomorrow. So you can pause this video if you need to right now so you can write that down and leave it up. But I hope you found this video helpful, and we're going to stop it right now.